Assalamualaikum dan salam sejahtera. My name is Muhammad Kaikal bin Kamaluddin. Matrix number B1223105883. This video intended to present the assignment 2, which is the individual assignment for digital communication BERT 3404 3403 assignment 2. Okay, next, we go through the question first. The question asked me to complete the incomplete MATLAB QPSK FDM system simulating circuit here to get the next three results between diagram 1, diagram 2, and diagram 3. Okay, next we go for okay, first we need to assign the MATLAB setting, which first m equals to 4. Next for the BLM and BLM 100 for setting time as time 1a minus 6. Next, set equals to 10 for the input configuration. Okay, after that, we go home, we push run button. Next, go home and then Simulink. Okay, next we go to Simulink. Okay, I already done the circuit. Alright, first we have data generation binary binary. A binary binary produces a stream of random binary bits by 0 second to 1 second to simulate the transmitted data. Next we go to QPSK. QPSK is quadrature phase shift keying. A group splits into pair and maps them to one of 4 phase shift, doubling the data rate compared to BPSK. Next, we go to IFFT, time domain conversion. It converts the modulated signal from the frequency domain to time domain for the transmission. Next, we go to noise introduction. Okay, signal visualization, which is we have used constellation diagram. Next, we go to FFT and then QPSK again for the modulation, pre-modulation, the group bits. Then we go to error rate calculation. All right. Okay, for the first setting, we need to set the lab just like what the lab report say, which is where we set Bernoulli generator first, then Gaussian noise generator, and then next QPSK. Okay, for the Bernoulli, we set probability of 0, 0.5, initial seed parameter, source of initial seed, we set parameter. Initial seed set 61, sample time set as time, sample per frame, and bilang star log 2 in bracket m, output data double, simulated using interpreted execution. Next, okay. Then QPSK, input type change to bit, constellation ordering gray, phase offset radians pi over 4. Same goes with the QPSK at the bottom. Output type bit, decision type hard decision, constellation ordering gray, phase offset pi over 4. Error rate calculation, receive delay 0, computation 0, computation mode entire frame, output data set to part, and then apply OK. IFT don't touch, divide output by FFT line, inherit FFT length from our input dimension. Next, okay. Next, FFT, just inherit FFT length from input dimension. Next, okay. And then last, we set Gaussian random signal. Random source, as random source distribution, we said is a Gaussian instead of uniform because we want Gaussian. Mean 0, variance set to 1, random generator setting, repeatability specify seed, initial seed I put rand seed. Next, signal property, sample time as time star log 2 in bracket 4, sample per frame and bilum, signal complexity I set real, output data set double, simulates using interpreted execution, push next apply and then okay. Okay, next we I push run button. Alright, wait until it processing. Then we got three output diagram. And the constellation diagram, first constellation diagram, based on the three constellation diagram result, this diagram together demonstrate how QPSK or FDM perform the noisy condition and how signal quality improves through different processing stages. Constellation diagram first represent the output during initial signal generation. This show a tight cluster of points near the origin. Next, constellation diagram 1. Constellation diagram 1 displays scattered points around the QPSK and represent the QPSK or FDM signal affected by Gaussian noise. Then they spread around each point, which is indicate the presence of noises. Next, we go to constellation diagram 2. Constellation diagram 2 displays more scattered signal, which indicate a clearer signal with reduced noises. It represents the received signal after demodulation and some form of noise filtering. This is, yeah. Okay, next we go to question 2. Construct an QPSK or FDM system in MATLAB as shown in figure 1 and obtain the result in figure 2 based on the specification below. Notes. Sometimes the block component can be replaced with similar block component in your library such as random source for Gaussian noise generator. Gaussian noise generator. Alright. In this circuit, I just need to delete the line, the way from Gaussian random source and then change it with the AWGN channel. After setting the specification, then I push run button. Then we get this. One here is in the first constellation diagram, there's a cluster of the signal, which is the noise not include not the signal is not filtering and the noise still there. Same goes to this constellation diagram 1, which is more concentrated. Next, we go to constellation diagram 2. In constellation diagram 2, here we see the noise finally dissipated because of the filter, just a little bit late after the constellation diagram 1, right? Okay. Next, for the second part, the final part, finally, modify the circuit with AWGN channel instead of using a random source generator to evaluate the result on different value of SNR. The value of SNR I'm using is 20 dB. The first one is 20 dB. Next, I change to 50. Then I got this. As we see, the first diagram, the filter is not go through the filter yet because of the high dB SNR. Second one, same. But the third, under the reconciliation diagram 2, uh, the filter is finally working, and it's so close with the origin, as we see to the 4 plus dot here. All right. Okay, next, first I'm using 20 dB, 50 dB, and for the rest, I'm using next 10 dB. Let's see what happens. All right, what happened here? Because of the lower dB, okay, in the first constellation diagram, the filter is not active yet. After the signal go through the first filter, it will become the filter is fine. The filter is working. Sorry, and the noise filtering. Sorry, the noise dissipates slowly. After that, at the end of the circuit, it will disperse. Is the noise will disappear, will disperse completely until a few dots, just a few dots or a few noises, just a little bit noises have. All right. Okay, that's all.